New technology, energy, sustainable economic development. This is ENEA's mission. The new company, launched in September 2009, benefits from the expertise, resources and experience of the companies that preceded it. Physician Eduardo Amaldi's CNRN in 1952, CNEN in 1960, ENEA since 1982. Over 2,800 researchers and technicians work every day in the 14 centres and research laboratories open to the country's science and business sectors. In over 50 years of activity, some of the biggest technological challenges in the country have been undertaken in these centres. Over 700 patents have been confirmed, and numerous high-level national and international projects. Studies and research undertaken in determined scientific domains are then applied to various environments, producing important technological innovations. One of the areas that has benefited from this migration between different disciplines is the cultural heritage sector, with more than 1,000 diagnostic interventions on important works of art, using gammographies, thermographic analysis, X-ray fluorescence, optic and electronic microscopy, and neutron tomography. These studies are vital for art historians and archaeologists to find out the origin and state of conservation of the objects or work, and sometimes lead to interesting discoveries, as happened recently in the near-infrared reflectography of 4 paintings made from Michelangelo's sketches, and finally attributed to Marello Venusti, his devoted copyist. The technique is used to reveal what is under the surface layer of the painting, and the archival research of scholars of this star of the Italian Renaissance led to one of the paintings being attributed to Michelangelo himself. Also, the industrial research carried out in ENEA has contributed to finding out about a particular piece of work of immense historical, cultural and religious value, the Sacra Sindone, the origin of which is still unknown. Experiments conducted to try to colour fibres using a laser in the textiles industry intrigued researchers at the ENEA Frascati Research Centre, who studied canvas and tried to reproduce the conditions and colour it, using special excimer lasers. With pulses of ultraviolet light, they managed to imprint and colour the external part of some lino fibres, with surprising results. What's important is achieving a colour as similar to the identical one as possible. A successful result has not yet been achieved. Often, the possibility to use a combination of different technologies has proved to be successful for ENEA, just like the ability to read and conserve cultural heritage in its natural context and environment. Geological experts work side by side with static consolidation specialists to secure national and international sites declared by UNESCO as sites of World Heritage and determine the cause of their denigration and suggest the measures to be taken. Important applications for the study and preservation of works of art have been developed from laser technologies created to check the state of structures inside nuclear reactors. With all the patented imaging topological radar technology, it's possible to detect, from a distance, the morphology and colour characteristics of a work of art and reconstruct a very similar image, with superior resolution compared to conventional methods. In this way, it's possible to monitor even large structures and identify variations in pigmentation or structural damage over time. For ENEA, examining cultural heritage is not just a technological challenge, but also an opportunity to contribute to the conservation of urban Italian landscape made of historic city centres inserted in their anthropological and environmental context. The interplay between culture and land, nature and history has shaped the architectural and urban forms of civil existence over the centuries. Each community has a completely original form, creating a priceless heritage that's unique in the world for its extraordinary variety and preciousness. Forming criteria for the rational use of energy, home automation, reuse of space and raw materials, use of renewable energy sources with components integrated into the site, and rationalization of the transport system are some of the future challenges for historic centres and are among the priorities of research and advanced services provided by the ENEA agency. The challenge is to win the project for the historic city centre of Vittorio Veneto, an urban nucleus of 90,000 square feet to be recovered with the objective of respecting heritage but also meeting modern demands. The buildings to restore have been studied using the most modern technologies for care and restoration, like the laser scanner, thermal imaging, georadar analysis and wall endoscopy. The key word in this project is sustainability, and in this case it means making the most of the architectural forms to facilitate lighting, heating and cooling to save energy as much as possible. It's not just a case study but a combination of experiences that can be repeated in other areas of the country. For over 30 years, ENEA has collaborated with the Protezione Civile on jobs following earthquakes, including the Friuli earthquake in 1976, then the one in Irpinia in 1980, the one in the Marche and Umbria in 1997, and the more recent one in Molise in 2002, and recently in Aquila on the 6th of April last year. From the first few hours following the earthquake, ENEA provides mobile structures, laboratories, technology, its researchers and experts, and a task force of 20 people from engineers to geologists. Macroseismic surveys are conducted to give an overview of the effects of an earthquake on territory. And on the basis of those surveys, the feasibility of construction and demolition plans for dangerous buildings or the recovery of safe buildings can be made. The agency's experience is enriched with surveys carried out in countries where earthquakes happen, like recently in Chile, where experts from ENEA and other Italian research institutes took part in a study under the guide of UNESCO. But, alongside the experience obtained via direct study of the consequences of natural disasters, the work is carried out in laboratories, considered centres of excellence on an international level for their abilities and equipment. Amongst them is the Laboratory for Material Qualification and Components of the Casaccia Research Centre in Rome, dedicated to research and experimentation into earthquake engineering, structural dynamics and vibration control. 2 vibrating surfaces, up to 6 degrees, amongst the largest in Europe, that reproduce the effects of seismic stress on structures along the 3 main directions simultaneously. Here, experiments are carried out on structural elements for buildings and scale models to test new devices like seismic isolators and energy dissipators. Earthquake protection for buildings of historical interest must harmonise the structural safety requirements with those of conservation. An historical building is untouchable, so to speak, right down to its foundations, because there are often crypts, decorative flooring, walls, cladding, and fittings which would be ruined by the insertion of seismic isolators at the base of the walls. The solution recently proposed by ENEA and the Politecnico di Torino for earthquake proofing of certain buildings in Aquila is to place an isolating platform under the foundations, inserting them using long horizontal tubes along which seismic isolation devices are then placed. Along the perimeter, a trench is dug that allows the building to move freely under the force of seismic waves. In this way, the whole structure is protected, using measures that do not alter the original architectural characteristics. The churches and buildings in historical city centres are treasures that conserve the heritage of the works they contain. Seeing them, observing them, and studying them is difficult and at times impossible. In this case, computers are a great help, and virtual reality makes it possible to cross physical and time barriers, reconstructing deteriorated works and getting a closer look at masterpieces that are usually only seen from a distance, like frescoes. In this sector, the agency has a powerful IT infrastructure, the ENEA Grid Network, with its beating heart, the Cresco supercomputer, a giant 25 teraflops for scientific computing, but available to business and institutions for investigating and studying art objects. Through the use of remote diagnostic tools, the network allows users who are located far away from the laboratories virtual access, visualization of the process, and data acquisition. ENEA research centres host schools and training institutions of every grade, who, through experimenting, discover models and technologies to preserve, enjoy, and enhance our historic and cultural heritage. The commitment to raising awareness in young people includes regional training centres and cultural districts, educational activities in the classroom and distance learning, and the technological transfer towards the productive world, with the involvement of young people, students and professionals. Scientific knowledge and humanities knowledge are two realities found in the application of new technologies to cultural heritage. ENEA has always contributed to bringing them closer together, with the unified objective of the sustainable development of the country.